G'day guys, Mr. Bennett here. Today we're going to be looking at the duplication or double angle formula, and again it's one of those things that I never remember. I just have on my formula sheet. What it allows me to do is to simplify things like sine of 2a down to sine a cosine a, or cosine of 2a, and obviously all the stuff is done without a calculator. Alright, so let's do the first sort of question over here. So if a is equal to 4/5, find the values of sine 2a. Alright, so if we're thinking about that, what do we know about the unit circle for number 1a? Alright, so we'll just do that using a unit circle. So 1a, so we do know that sine of a is equal to 4/5. Now, if we're thinking of sine of 2a, looking at the formula there, the only thing that we can actually write that as is sine of 2a is equal to 2 sine of a times by cosine of a. Alright, so what we need to know is we need to know what cosine of a is, if that's the case. Alright, so if we're using our unit circle, alright, then what we can do is we can actually work out what cosine of a is. Right, so sine of a is 4, 5. Now that's a 3, 4, 5 triangle, so we know the side over here is 3. And then obviously sine could be that. So therefore that could be 5, 4 and minus 3. So in this case here, cosine of a could be equal to 3/5, or it could be equal to minus 3/5 in that particular case. Alright, so if that's the case, let's just do the positive one first of all. We would know that's equal to 2 lots of sine of a, which is 4/5 times by 3/5. Alright, so when we times that all together, 2 times 4 is 8, times 3 is 24, and then 5 times 5 is 25, so it's going to be 24 on 25. So that's what sine of 2a would be equal to. Or you could say that sine of 2a is equal to 2 lots of 4/5 and minus 3/5. So that will give you the same value, which is going to be minus 24 on 25. Alright, so you got 2 possible values for that, the concept there. Alright, so that's essentially what you're doing. Now obviously if you're doing the cosine, I've just made a mistake because I didn't read the question. It's easy to do that. I've already been told what the cosine is, so I have to ignore that bit there. Okay? And you didn't really have to do that as I did this in the question. But if you didn't know, that's what you'd have to actually do. You'd have to actually look at both of those scenarios. So the trick here, I suppose, is make sure you read the question carefully. In this next one though, we're only given the cosine value of that equal to 1/3, and we have to find cosine of 2a. Now, because you've only been given the cosine, then what I would do is I'd pick one of these things which has only got cosine in it. So if I was doing that one, number 2, I'd be using the relationship which is 2 cos squared a take 1. So you use basically what you've been given, right? Again, if I was doing part 3 over here, because I've been given 2 cos phi, and I know what sine is, I'm going to use the one with sine in it. So I'm going to say that's equal to 1 take 2 sine squared phi. Okay, so that's the relationship you're going to use because that's what you've been given over here. In the first one, though, because I do know what sine and cosine is, I'm going to say that's equal to cos squared a take sine squared a. Right, so actually using the things that I have. So you have to look at what you've got in terms of the duplication formula and what you need to find. So that's the first type of question. Then coming down to something like question 4, if you've got a sine theta, and this is where I was probably working before, then I have to work out what sine of 2a is. Now I know that automatically is 2 sine alpha cosine alpha. And I know my angle is between pi and 3 pi and 2. So for this one here, I need to use my unit circle. In the first one I showed you, I didn't really need to use it because I already had the answer. So here we know that sine's equal to -2, 3. And so therefore that's 9, that's going to be 4. So this here is going to be the square root of 5, isn't it? Using Pythagoras, and it's going to be minus. So here we know that cosine of alpha is going to be equal to -√5 over 3. So that's the first thing you do is use your unit circle. And now to actually find 4a, all I need to do is say that 2 sine alpha cosine alpha is going to be equal to 2 lots of, well, we know the sine's equal to -2 over 3, and we know the cosine's √5 negative over 3. So therefore that's going to give me positive 4 √5 over 9. So that's what that's going to be equal to. Alright, same sort of process that you would do for the next one. I don't know what, I know cosine, but I don't know what sine is. It says find the value of sine and hence find the value of 2 sine. So in this particular case, again, I use my unit circle. In that case, I would be going over here and I would be using that there. And I know cosine is simply 2, 5. So therefore 25 take 4 is 21. So therefore that's going to be √21. And it's going to be negative √21. Alright, so you can simply find your value and then times that through quite quickly. Okay, so it's actually a useful process, certainly using your duplication formula, to find and simplify things where you have double of the angle. Alright, and so therefore these are on your formula sheet that I'll give you. Alright, so it's just a matter of now identifying what you've been given, what you've got, and what you need to find. And that's the same in most things that we do in maths. Alright, keep in mind, don't make the mistake I did in the first part, which is if you're already given what the cosine is, you don't have to do any more than just use what they give you. It's only in these ones here when you, like question 4 onwards, where you actually have to find the value of the sine or the cosine and then use that with the relationship that you've got. Alright, so generally in a test, I'll probably ask something like one of these questions here, just to see if you can use a unit circle and if you can use the duplication formula. Alright, so make sure that you work through that exercise. Alright, it's really important that you get the concepts.